Hello everybody, welcome back. This video we're going to talk about dilations with the coordinate plane. First example, triangle ABC has vertices at A, 0, 6, B, 8, 2, and C, 8, negative 2. A dilation with a scale factor of 1/2. And center at the origin is applied to the triangle. What are the coordinates of B prime in the dilated image? So what's going on here is we're just focusing on the point B. And then we have the dilation of 1/2, and we want to know what are the new coordinates. Well, all you do is take half the value of the coordinates from B, and that would be our what we call B prime, our new value. Half of 8 is 4, and half of 2 is 1. So the new coordinates after the dilation would be 4, 1. Let's look at the next one here. It says a dilation with a scale factor of 3.5 centered at the origin is applied to AB with endpoints. A is 2, 5, B is 2, 1. What are the new coordinates of A prime, B prime? All right, so again, take this dilation, multiply it to each of the coordinates in A and B, and that's going to give us the new values for what we're going to call a new point, A prime and B prime. If we take 3.5 times 2, we're going to get 7. It's the new x coordinate on A. And then 3.5 times 5 is 17.5. For B, 3.5 times 2, 7 again, and 3.5 times 1 is 3.5. Those are our new coordinates after the dilation. Now, kind of looking at this from a different view, we have rectangle ABCD has vertices A, which is 1, 1, B, which is 1, 7, C, 3, 7, and D, 3, 1. And the dilation with the scale factor of 0.4 centered at the origin is applied to the rectangle. Which vertex in the dilated image has the coordinates of 0.4, 2.8? All right, well, just so you're understanding what's going to happen here, all 4 of these points get dilated by a factor of 0.4. So picture getting multiplied by each of those. Now, one of them ends up with 0.4 and 2.8. And the one that wins, I believe, is B. B is the one. When you take 1 times 0.4, you get the 0.4. When you take 7 times 0.4, you get 2.8. So for this problem, point B, which turns into the new point B prime, has these coordinates here, 0.4 and 2.8, after the scale factors applied and multiplied by 0.4. On the next one here, we're going to be determining what is the scale factor. It says a smaller triangle is the dilation of the larger triangle with a center dilation at 1, negative 1 down here in the corner. What's the scale factor of the dilation? The smaller triangle is the dilation. That means it started big, started with the big triangle, and then it turned into the small. So that's going to be a reduction. Whenever an object gets smaller, it's a reduction. The scale factor's got to be less than 1. The way we can do this, first of all, let's review that when you find a scale factor, a measurement or a value from the second object, we're just going to call that the second number. We divide it by the first or the original measurement number. That'll tell us the scale factor. All right, so we end up with the smaller triangle. I'm just going to focus on one measurement, the base of the bottom triangle. That has a value of 2. We can think of that as our second number. The original image, the big triangle, I'm going to focus on the base of that from here to here. And it seems to have a distance of 8. We count 1, 2, 3, 4, 5, 6, 7, 8. And that is where we started. That was the original value. So we think of this as 2 over 8. Reduce that 1/4 or 0.25. The scale factor is 1/4. The second triangle, the smaller triangle, is 1/4 the size of the larger triangle. This dilation was a reduction, scale factor less than 1. Finally here, it says AB has endpoints 1, 4 to 8. A dilation centered at the origin is applied to line AB, and the image has endpoints A prime, which is, if you look carefully, 1/8 and 1/2, and B prime, 1/4 and 1. What's the scale factor? Again, determining the scale factor, second number over the first. In this case, we actually have 4 choices: the x coordinates from A, the y coordinates from A, the x coordinates from B, and the y coordinates from B. We can choose any of these and work to find the scale factor, and we get the same result. I'm looking at all the values here with A prime and B prime. Most of them are fractions except here. The y coordinate on B, if we use that as our template to figure this out, so to speak, think of the y coordinate as B as our second number, 1. The y coordinate on B, the original B, 8, 1/8, that tells us our scale factor. Now, just to prove that, hey, we could have used any number, let's test it out with the y coordinate of A prime, the y coordinate of A. Let's see if we do, in fact, get the same result. In this case, our second number, 1/2, and the original number is 4. 1/2 divided by 4, I can rewrite that as 1/2 divided by 4 over 1. Dividing fractions is just like multiplying by the reciprocal. 1/2 times 1/4, we still get 1/8, don't we? So it doesn't matter which one, in a problem like this, it doesn't matter which one you use. But we're going to use I originally used the 1 here and the 8 just to give us a number without fractions. Thank you for watching. Hope this clarifies the concept of dilations on the coordinate plane.